A database is far more than a hard drive where your data sits for decades. It's a full system engineered to store, retrieve, protect, and organize information in a safe, consistent, and insanely efficient way. A proper database handles many users accessing the same data simultaneously. It keeps everything consistent, even when errors occur. It allows you to search millions of records in milliseconds, ensures nothing is lost if hardware fails, and it even manages indexing, caching, transactions, and concurrency behind the scenes. It's not just storage, it's a data engine. So when people talk about databases, you'll almost always hear two categories: SQL and NoSQL. Two philosophies, two models, two very different ways of structuring data. SQL stands for Structured Query Language, a language created in the 1970s and still the backbone of modern data systems today. A common misconception is that SQL is a database. No, it's the language databases use to communicate. SQL databases organize data into tables. Think spreadsheets with rows and columns. Every table has a schema, clearly defining what fields exist, what types of data do they store, and how tables relate to each other. Most popular SQL databases are Postgres, MySQL, Microsoft SQL Server, or Oracle. SQL databases are ideal when your data has relationships and structure. Think users, accounts, transactions, merchants, or companies. These aren't just loose documents. They connect to each other through clear relationships. SQL databases handle this beautifully. They also guarantee correctness through constraints, foreign keys, unique indices, transactions, and isolation levels, which in simple terms means that operations are either complete fully or not at all. Nothing's partial or corrupt. This so-called ACID compliance is why industries like finance, healthcare, and e-commerce rely on SQL systems. But hey, what about NoSQL? NoSQL databases take a very different approach. They shine when data is unpredictable, schemaless, or semi-structured, and it spreads across many servers or it changes rapidly. Think logs, analytics, caching, or event streams. This is why many real-world systems use both SQL and NoSQL. A company might use Postgres for user accounts and business logic, MongoDB for flexible content, and Redis for caching and sessions. This is called polyglot persistence, using the right tool for each job. But when learning full-stack development and when building the vast majority of practical business applications, SQL is the ideal foundation. Okay, so we've decided. SQL it is. But which one? MySQL? SQL Server? Oracle? Postgres? Among all SQL databases, Postgres stands as the most powerful, modern, and open-source relational database in the world. Developers consistently rank it as the most loved SQL database, and not by accident. A couple of reasons why it's so great is that it's truly open source, so developers can use it freely for commercial apps, startups, or even cloud platforms. It has many cool features, supporting data types like JSON, arrays, IP address types, and even custom types you define. You get flexibility without losing relational structure. It also includes built-in full-text search, window functions, common table expressions, and advanced indexing, which means you can express incredibly complex logic with elegant queries. It's also serious about data integrity, so it's fully ACID compliant, protecting your data from corruption. It has great performance, best in class, handling joins, aggregation, and complex queries efficiently, even with large datasets. And it also has a legendary community. Documentation is great, tutorials and examples are everywhere, solutions to almost every problem already exist, and modern AI systems work beautifully with Postgres's structured data and metadata. So for modern web development, especially for learning, Postgres gives you enterprise-grade power for free. But here's what most tutorials don't tell you. Knowing what a database is doesn't make you ready for real-world systems. Your database isn't just storing rows. It's handling connections, locks, indices, query planning, background jobs, caching, concurrency, and traffic spikes. And when something slows down, breaks, or behaves oddly, you need to know exactly why. This is where developers separate into two groups. Those so-called vibe coders who hope everything works, and engineers who understand their systems end to end. And the new AI-driven world you're entering rewards the second group. This is where I want to introduce you to Site 24/7, which gives you real-time visibility into your Postgres server and your backend. It detects your slow queries, CPU and memory analytics, disk performance, connection usage, transaction behavior, and even spikes and anomalies. So whether you're deploying a side project or preparing a production app, monitoring is not optional. It's part of building real software. Since later in the course, we're going to integrate proper monitoring using Site 24/7, let's go ahead and create an account right away to make our job easier. Now that you know more about databases, it's time to learn the P in the PERN stack.